My name is AMIRUL ZURAIMI. My meeting number is 2022 800 and 408.
Hi, in this video I want to explain question 2 part A, which is sketch the graph. So the fx is, and the x is, so here we can see this one, which is the scale. Firstly I want, if to make the graph, I make the graph file first. So this line for fx, and for x, follow for this one I will make it pi, 2 pi, 3 pi, 4 pi, and here pi, 2 pi, 3 pi, and 4 pi. Here I will make 1, 2, 3, 4, 5, 0, 1, 2, 3. So how to make the graph? We pick this function, the fx, 2 over pi times x plus 2. So the x is negative pi. So we sub this negative pi into x, and the value will be 0. So the fx is 0 and x is negative pi. The mark will be hit. And the second mark, the x is pi, and this pi sub into this x. Then the answer of this fx is 4. So fx is 4 and x is pi. The marks will be here. So I will make a straight line from this mark to the second mark like this, and then repeat it to the right side and the left side like this. Next, determine whether the function is even, odd, or neutral. I will do this with f negative x equal to 2 pi, and the x is positive x plus 2. Therefore, fx equal to 2 pi times x plus 2 is n odd function, since fx is with x for all x in the function. That's all. Thank you.
My name is Muhammad SYAFIQ bin Muhammad JURAIMY. My student ID is 2022844112.
Okay, I will solve the question 2b. Okay, question 2b, we must find the AO and BN, A0 or BN. So the given for Fourier coefficient is AN is equal to 0. So to find AO, first we wrote the given from the question. So first, fx is equal to the 2x over pi plus 2, and fx plus 2 pi is equal to fx. So from the question, we must solve it in a Fourier series. So first, we must find the value of L. So to find the value of L, we will using this formula, which is fx plus 2L, and we compare it with the given in the question, which is fx plus 2 pi. So and then when we compare, we get L is equal to the pi. Okay. To find the fx, we will using the general formula for Fourier series, which is A0 over 2 times summation of an cos n pi x over L plus bn sin n pi x over L. So first we must find the Fourier coefficient for AO, which is AO. To find AO, we'll be using this formula. AO is equal to 1 over L times the integration of function given. So we know that L is equal to the pi, so we just substitute the value of L with the pi, and fx is already given in the equation, which is 2x over pi plus 2. So we just substitute it, and then we just integrate it. When we integrate, we get 1 over pi times x square over pi plus 2x. So we know that the limit is pi and negative pi. When we integrate, we must minus it. We substitute the 2 of the limit and minus. So when we substitute, we get 1 over pi times bracket pi square over pi plus 2 pi, and minus with the limit for negative pi, which is negative pi square over pi plus 2 times negative pi. So when we substitute, and we get 1 over pi times pi square over pi, we got pi and plus 2 pi, and minus pi square is equal to pi over pi. We got pi, and it times with the negative, we got negative pi, and 2 times negative pi, we get negative 2 pi, and times with the negative, we got positive pi, positive 2 pi. Then we just multiply it like usual, and then we got, and we just sum all equation in the bracket, and we got pi plus 2, pi is equal to 3, minus pi, we got 2, and plus 2 pi, we got 4 pi. And then we got 1 over pi times 4 pi, we got 4. So this is the value for A0. So that's all for me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Hazeq bin Misuan. My student ID is 2022-876254, and I'm from EMK for M2D. So next, I will continue for the next part, which is to find Bn Fourier series. To find Bn, the formula for Bn is, so the value of L that we found earlier, we will plug in back in this formula. The function that given is, the pi over here can be cancelled out, so it will left. Next, we will integrate this equation. To integrate this equation, we can use tabular method. So for the differentiate, we will use the equation 2 over pi x plus 2, and to integrate, we will use sine nx. So the value of the negative and negative will be positive, so there will be no negative over here. Then we will solve this equation. So first of all, we will plug in the pi or in the x. Then we can cancel out this value. This value also can be cancelled out. So this one will be left with 4. So negative cos n pi, negative cos pi will become negative 1 if we calculate in the calculator, and sin pi will become 0, and all of them will become 0. Next, minus with 4, and negative 2 plus 2 is 0, and sin n pi will become 0, will become also 0. Sin n pi will become 0, and the final answer will become. In the final step, we will plug in all the value that we found earlier in the general formula for the Fourier series. So that's it for the final answer of the question number 2. So that's all from us. Thank you.